So here's our first example of that first application of exponential growth, which we often see applied to continuously compounded interest, which is also what we're going to look at. So it'll take a moment to write this. If we were in class, what I would have done was type all of these examples up and then just kind of hand them out so you wouldn't have to copy all that over. But of course, that's not the situation we're in. So here we go. A large bank offers a certificate of deposit, often referred to as a CD. It earns 4.9% compounded continuously. How much will a CD for $10,000 earn in 4 years? Okay, so when you get one of these, in the homework or test, you'll have to recognize which type of which application it is, which formula goes with it. So this one, is one of the easier ones to identify, right? It says compounded continuously there, and we're talking about how much is earned and all this thing. You also notice that this kind of question, this very question could have been asked back in an algebra class if we knew the formula for continuously compounded interest. We maybe remember what that is, but we can approach this from like a step back in like the logic, right? So we can approach it from the differential equation perspective. And the truth is, the solution to the differential equation is that formula that we learned back in algebra. So we're kind of going one level deeper almost and solving it from that end. Okay, anyway, this is what we're looking at. So we've got the exponential growth differential equation there, the general form of it. Every one of these applications is going to have some kind of an initial condition. So here it's going to look like, A will have some value of t equals something. So really, I shouldn't even put this t there. That should be a question mark. A of what equals what? Since our function is a. All right, well, let's think about the differential equation first. We're going to fill in the value of r so that we can go about solving this. And you might realize, oh, r, well, that's the interest rate, 4.9%. We're going to fill in 0.049 for r. Okay, I'll show you that in just a second. How about the initial condition? So there's one piece of information that they tell us, right? The other number they give us is the 10,000. So it turns out at time 0, this certificate of deposit is worth 10,000, right? So at 0 years past, when t is 0, the amount is 10,000. So here's how we're going to start this thing off. dA over dt equals 0.049a, and a of 0 equals 10,000, the initial amount. Okay, obviously the initial condition will come later. We need to solve our differential equation, and we're going to do that in the separable style. Turns out this is a really simple separable differential equation. It's not uncommon here in the applications. Usually what's hard about the applications is just setting it up. But if you're familiar enough with practicing, how to solve these things, then they're usually not the harder versions. They're usually the easier versions once you have them set up, which is really nice. So let's go for it. Hey, this is separable. So we want to get the a's on one side and the t on the other. Well, we don't have any other t's, so we're just going to, oh, there's my hint. It's all by separable. Okay. So we're just going to divide that a. And of course, we'll multiply the t also, the dt, excuse me, and we'll integrate both sides. And we'll be left with this. Again, even here, pretty simple, taking our antiderivatives, once you kind of settle in, right, we've got the natural log of a, absolute value of a technically, 0.049t plus c, and that right there is an implicit solution to our differential equation. Now, I suppose If we wanted to, we could find the explicit solution. If we were in class, maybe I'd kind of put that out to you guys if you wanted to explore that, what the what the explicit solution would look like. And it might remind you of that formula that you learned back in algebra. You know what? Now that we think about it, I'm just gonna write it out here. We would apply an e to both sides to isolate the a, and it would turn out to be c e to the 0.049 t. You might recall this equation back in algebra. A equals p e to the rt for continuously compounded interest. Maybe, maybe not. If we went about it, and there's kind of a subtlety here with the c, how it ends up right there. But if we solve for a, we could simplify it down to that. Again, I didn't do that here. Turns out this implicit form is perfectly fine for our purposes. So if you're more comfortable just stopping at this point, then let's see how we would continue. We're going to now apply our initial condition, which means we plug in 0 for t, we plug in 10,000 for a, just like so. And we can use that implicit form without any problem. Actually, it's almost preferred because we're trying to solve for c, right? We multiply by 0, and c is simply the natural log of 10,000. Okay, so what do we do with that? Well, when you solve a particular solution, once you have the value of c, you take that and you put it back in to the c in your solution. And I even named exactly what we're looking at here. So a moment ago we had our general solution. Now we've got a particular solution, and of course it's implicit. Now this is really good. We've solved the differential equation. We looked at it with the initial condition. This is what we need to answer the original question. At this point, let's look back. What exactly did they ask? How much will a CD for $10,000 earn in 4 years? Okay. To answer the question, we'll say, okay, I've got this equation. It's got the amount. It's got the time. How much will be earned, right? We need to know the amount after 4 years. So we're going to plug in t, and at this point, we will need to solve for a, but it'll be a lot easier when we're just working with numbers. So after 4 years, okay, we'll put in 4 for t. Natural log of a equals 0.049 times 4 plus the natural log of 10,000. And let's just kind of speed our way along to the answer. At this point, I crunched that in a calculator and rounded it and got this. I put it to 3 decimal places. I don't know, that seemed accurate enough to me. 9.406. To get the a, obviously we need to put both sides in the power of e. So a equals e raised to the 9.406, which is 12,161.129. Again, I rounded to 3 decimals right there. Now you might be thinking, well, we're really talking about a dollar amount. So wouldn't it be appropriate to round this to the nearest cent? And yeah, definitely. Let's say the amount after 4 years is $12,161.13. That's pretty good. That's pretty good. Now it's tempting to say that this is our answer, right? That's how much is in the account, or how much that CD is worth after 4 years. Turns out that's not exactly what they asked. They asked how much did the CD earn, implying interest. Just how much interest did it earn? So we need to subtract the original 10,000. $2,161.13 is how much it earned. So, obviously be careful when you're answering your final question. It's not going to be unusual for them to ask simply how much it's worth. But, if it's how much interest is earned, right, be careful to only answer how much was earned. All right, well, that was our example for the first application. We'll do the next one in the next video.